In this video, I will explain the Lineweaver Burk plot. So what is the Lineweaver Burk plot? Well, to understand what a Lineweaver Burk plot is, we must first go over the Michaelis-Menten curve. It is based on the Michaelis-Menten equation and shows the rate at which an enzyme can catalyze the chemical reaction. As substrate concentration increases, the enzyme is overwhelmed and reaches its maximum production speed, known as the Vmax. The Km is 1/2 of Vmax, and a lower Km means a higher enzyme affinity for that substrate, since it takes less substrate to reach its maximum production speed. We can use the Lineweaver-Burk plot in order to better view the Michaelis-Menten diagram. So how do we get a Lineweaver-Burk plot curve from a Michaelis-Menten? If we simply take the reciprocal of the Michaelis-Menten equation, we get this, which is like the equation of a straight line, which is how we create our Lineweaver-Burk plot.
On this curve, the x-intercept shown in gray on the left is the negative reciprocal of the Km value, and the y-intercept shown in pink in the middle is the reciprocal of the Vmax.
As a reminder, enzymes can be inhibited by competitive and non-competitive inhibition. In competitive inhibition, the inhibitor fights the substrate for the active site, which ends up altering the Km since more substrate is needed to beat the inhibitors and get to 1/2 Vmax speed. In non-competitive inhibition, an inhibitor simply deactivates the enzyme's active site, which lowers the Vmax as some enzymes are inactivated. The Lineweaver-Burk plot makes it easier to visualize these modes of enzyme inhibition side by side, as it uses straight lines and it's easy to make out where the Km and Vmax values are, whereas the Michaelis-Menten curve can look undetermined in terms of Km and Vmax values. One example of the Lineweaver-Burk plot being used is in testing alcohol dehydrogenase inhibitors. Alcohol dehydrogenase is the enzyme that helps the body eliminate toxic alcohols like ethanol by converting them into acetaldehyde and so forth until it is eliminated. Myricetin demonstrated classical competitive inhibition. The Km increased upon addition of this inhibitor. This is shown on our diagram by converging y-intercepts and reduced x-intercepts upon increasing this inhibitor's concentration. So, imagine you have 3 different classes scattered inside of a gym, and you're trying to see which class has the tallest students. The Lineweaver-Burk plot is like making all the students line up in their own classes from shortest to tallest and gives you a clear view of the Vmax and Km. So, is the Lineweaver-Burk plot just the best? Well, not exactly. It is useful for comparing enzyme inhibition types and allows direct determination of Vmax and Km from your XY intercepts. However, low substrate concentration values dominate the plot, which can amplify any experimental errors that were made. And the Vmax and Km often lie outside the range of experimentally measured data. This means you're estimating your values based on a line beyond your actual measurements, which can introduce error.
That's all, folks.